Good morning. Today we're going to talk about section 2.3 in our text entitled Slope of a Line. Alright, well, we all have had contact with slope in our mathematical careers. Let's review a little bit. Slope, we usually reserve the letter M for slope. M, if you don't know, it's from the French verb monter. Monter means to climb. And over the years, this notation has evolved. Slope we refer to with the lowercase letter m. All right, as we know, the slope is usually simplifies to a number which measures the steepness of a line. You do a simple example here. If we have, let's say we've got a line, any non-vertical line, let's call it. And let's say this non-vertical line has 2 points on it. I'm going to label one of the points x2, y2, and I'm going to label the other point on the line x sub 1, y sub 1. Alright, if I draw what I call a little slope triangle between these 2 points, basically describing the horizontal and vertical distance between those 2 points on the line, I can define slope rather easily. Slope, well, informally, it's the rise of a line between 2 points divided by the corresponding run between those 2 points. Well, my rise is really my change in y coordinates. I think we can see that the distance, the vertical distance between these 2 lines is going to be the simple difference in the y coordinates. So my rise I will define as y2 minus y1, where y2, y1 are the corresponding y coordinates of those 2 points on the line. And the run, of course, is going to be the difference of the x coordinates, x2 minus x1. Well, the horizontal distance between these 2 points. If we want to be a little informal about it, often slope is referred to as delta y over delta x, where of course delta means change in y, delta y means change in y, and delta x means change in x. Okay, and again, this is a number which measures the steepness of a line between 2 points of interest. Alright, so that is our definition of slope. Let's get to a couple of examples here. Find slope of line through 2 given points. I'm going to say the line between minus 2, 4 and 3, minus 4. Alright, what I usually do is when I'm given 2 points like this, I'll label one of the points x1, y1 and the other point x2, y2. It doesn't matter which one you label x1, y1 or x2, y2. It all comes out in the wash. I can use my slope formula then, y2 minus y1 over x2 minus x1. Be careful of the signs here. I'll get a minus 8 in the numerator, and 3 minus minus 2 gives me a positive 5 in the denominator. Alright, so the slope of this line is minus 8/5. Let me take a minute to graph this line in the xy plane because I want to illustrate something. If x is minus 2 and y is 4, puts me up here. If x is 3 and y is minus 4, puts me down here. Alright, let me label these points with the coordinates minus 2, 4 and 3, comma, minus 4. And let me sketch the graph of that line between those 2 points. Let me draw my slope triangle between these 2 points, breaking the travel into horizontal and vertical components. Well, I can see my change in x, my run between those 2 points, is going to be 5 units. I travel 5 units from left to right, and I'm going to put a positive sign on that 5 if we're going to make the assumption that left to right travel is a positive run. If I then label my rise, well, notice my rise is really negative. I go from a positive 4 to a negative 4. I'm really falling, and my rise I would characterize as a negative rise. My rise here is negative 8. So if I travel from high to low or travel down, my rise is negative. Alright, so using this graph, graphically I can determine also that the slope is going to be minus 8/5. Okay. One thing I want to highlight, notice this slope is negative. And if you've got a negative slope, well, I know that for a positive rise, or positive run, I should say, my rise is negative and my line is falling left to right, and we call that a decreasing line. So negative slope means decreasing line as indicated in the graph. Let's do another example of this. Example. Find slope of line through minus 2, minus 1, and 2, comma 7. Alright, I'm not going to bother to label these. I'll just go right to my slope formula. y2 minus y1, be careful of negative signs, divided by x2 minus x1, letting my second point be x2, y2, and my first point be x1, y1. Alright, so my numerator is 8, my denominator is 4. Of course, that reduces to 2 over 1, which gives me a slope of 2. Alright, now a slope of 2. Well, let me quickly sketch a graph of this line also. Only takes a minute. If x is minus 2 and y is minus 1, puts me about here. And if x is 2, y is a positive 7. 1, 2, 3, 4, 5, 6, 7. Puts me up here. And let me connect those 2 points. Doing my best freehand with the tablet. All right, let me make the points real big so we can refer to them. Let me label these points. This point is 2, comma 7. This point is minus 2, comma minus 1. And if I draw my slope triangle here between these 2 points, well, we can see I've got a run of positive 4. Notice this, maybe not so easy to see on the hand-drawn graph, but my x goes from a minus 2 to a plus 2, and indicating a run of positive 4, right? Run of positive 4. What's my rise going to be? Well, my rise, if I go from minus 1 to positive 7, well, you can see you're traveling 8 units in a positive or up direction, so my rise is going to be positive 8. Again, the convention is if you're traveling up, your rise is positive. Going up, your rise is positive. Alright, so my slope is my rise over run, and that's positive 8 over positive 4, and that's of course a 2 over 1. Which of course is 2. Alright? Now another thing I want to highlight here, if you've got a positive slope, that means your line is increasing left to right. Alright, so positive slope, N2 is positive, you've got an increasing line. Alright, so negative slope, decreasing line, positive slope, increasing line. Alright, so we've done a couple of examples of slope calculation. I want to investigate slopes of horizontal and vertical lines here. Let's talk about that. Slope of horizontal and vertical lines. Alright, I'm going to talk about this a little abstractly. If you've got a horizontal line, well, we know from our last section that means y equals constant. Right? Y equals constant always gets you a horizontal line. Right? Well, if your y is constant, what does that tell you about the rise of this line? Well, remember your rise between 2 points is always the difference in the y coordinates. But if y is constant, your rise will be 0. Okay? So if I go to compute my slope, in a horizontal line, the numerator will degenerate to 0 always. It really doesn't matter what your run is. If a fraction has a numerator of 0, the fraction equals 0. 0 over anything is 0. Well, the long and short of it is, if you've got a horizontal line, your slope is 0. Okay? Alright, let's talk about vertical lines. Somewhat similar. Well, if your line is vertical, recall your equation looks something like this. That means x equals a constant in a vertical line, as we saw in our last section. Implies the run, namely the difference in the x coordinates is always going to be 0. So when I go to compute my slope, well, there may be a rise. Well, the idea here is your run will always be 0 in a vertical line. And division by 0 is not defined, so we handle it like this. We say there's no defined slope in a vertical, in a vertical line. I like to think of vertical lines as having infinite slope. It's all rise. There is no run. But our book, and many books, and some books say no slope, some books say no measurable slope. Our book says no defined slope. Okay? Alright, so horizontal lines, 0 slope. Vertical lines, no defined slope. Hang on. Alright, I want to talk about parallel lines next. And the relationship between slopes of parallel lines. Well, if lines are parallel, that means they never intersect. And if they never intersect, I think you'll agree with me that implies the ratio of rise to run must be the same, else they will hit somewhere down the line. Well, this is kind of a intuitive statement. Parallel lines have equal slopes, and I imagine we all knew that. Okay. Parallel lines have equal slopes. All right, not quite so simple with perpendicular lines. Perpendicular lines. Well, perpendicular lines by definition intersect at a 90-degree angle. I'll try to simulate that here. All right, perpendicular lines intersect at a right angle or 90-degree angle. Okay. All right, certainly their slopes are not equal. And I'm not going to prove this. The author does prove it in the text. I'll leave that reading for you. The perpendicular lines have what we refer to as negative reciprocal slopes. And that means just what it says, if reciprocal slopes. Okay? That means negative and reciprocal. Let's do a simple example here. Let's say we've got line 1 and line 2. Let's say line 1 is parallel to line 2. And let's say slope of line 1 equals minus 3/2. Well, that means the slope of line 2 is going to have the same slope. Parallel lines have equal slopes, okay? Let's say I've got two different lines, L1 perpendicular to L2. Okay, this notation meaning the lines are perpendicular to each other. If line 1 has a slope of minus 3/2, what's the slope of line 2 going to be? Well, remember, perpendicular lines have negative reciprocal slopes. That means just that. You negate and reciprocate. So minus 3/2, the negative reciprocal of minus 3/2 is positive 2/3. Right? The negative reciprocal of negative 3/2 is positive 2/3. Okay? All right. The book winds through some problems of this type: parallel, perpendicular, or neither. And these are Regents type questions, so you've probably seen them before in your careers. Let's consider line 1. And let's say I don't have the equation of line 1, but I do know it goes through two different points. Let's say through minus 1, 0 and 6, 7. Let's say I've got another line, line 2. Through two different points. And I'll ask the question here: are these lines parallel, perpendicular, or neither? Well, to make that judgment, we got to find the slope. So if I look at line 1 and I'm going to compute the slope of line 1, it's going to be y2 minus y1 over x2 minus x1. And my slope is going to be 7 over 7, which of course reduces to a positive 1. Alright, let's compute the slope of line 2. And then we'll make a judgment. y2 minus y1 over x2 minus x1. 5 minus minus 2 is 7 on top. 4 minus minus 3 is 7 on the bottom. And the slope here is also 1. Alright, well, if line 1 has a slope of 1 and line 2 also has a slope of 1, the slopes are the same and the lines must be parallel. Parallel lines have equal slopes. Okay? Let's try another example. of this type of question, consider another two lines. Line 1. Let's say it goes through -1, 3 and 2, 5. Let's say L2 goes through two different points, 3, 0 and 5, -3. And we ask, are these lines parallel, perpendicular, or neither? And of course, to make that judgment, we've got to compute the slopes. The slope of line 1, I'll call it M1, is going to be 5 minus 3 over 2 minus -1. Alright, so I end up with 2 in the numerator and a 3 in the denominator, so the slope of line 1 is 2/3. Let's look at slope of line 2. -3 minus 0 over 5 minus 3. Alright, so my numerator simplifies with -3, my denominator is a +2, and my slope is -3/2. So I've got slopes that are negative reciprocals. They are both negative and reciprocal of each other, and negative reciprocal means, of course, perpendicular lines. So my answer to this question would be perpendicular. Hang on a minute. Perpendicular. Okay. All right. Here's an example of a question that I see students getting wrong and sometimes wasting a lot of time on. Find slope of line through -7. And sometimes they'll punch their calculator buttons incessantly when really a moment's reflection should give you the answer here. Do you notice anything about these 2 points? I noticed something. The y-coordinate on both points is the same. What does that mean? Well, that means in these 2 points, y equals constant. And when y equals constant, when y is constant between any 2 points on the line, you've got a horizontal line, right? Remember, y equals constant, horizontal line. And horizontal lines always have a slope of 0. So really no calculation needed there, just the observation that these 2 points have the same y-coordinate. Similarly, find slope of line through -8, -3, and -8, 29. Alright, many students have trouble with a problem of this type. It's a 29 there. They'll start plugging points in, coordinates into their calculator, and they end up getting an error message when they compute their slope. Well, that should tell you something. You notice anything about these 2 points in particular? The x-coordinates are the same. And when x-coordinates are the same between 2 points, that means x equals constant. X is not changing. And when x equals constant, you've got a vertical line. And vertical lines have no defined slope. The slope is undefined. It's infinite. And that's why you get an error message on your calculator when you try to grind out the slope with a calculator. All right, so again, just a moment's reflection here. All you need to know is that x coordinates are the same, x equals constant, vertical lines have no defined slope. All right. One more example. Another parallel, perpendicular, or neither type question. Well, with a little bit of a wrinkle here. Consider L1 through these 2 points. And remember, all you need is 2 points to determine a line, really. And consider L2 through these 2 points. Minus 14, 4, and 9, 4. Alright. Now, I suppose you could go jump to the calculator and start punching buttons, but I'm hoping we could be a little more observant here. Let me write down the question. Are these parallel? Are these perpendicular? Or are these lines neither? That's the question at hand. I hope you notice, in the light of the 2 previous examples, the x-coordinate is constant between those 2 points. That means a vertical line. That means the slope is not defined. Alright, so the slope of line 1 is undefined. You write that down. M1, slope of line 1 is not defined. I'll just write down no defined slope. That's how our book handles the vertical line situation. Alright, L2. Well, again, I'm hoping you'll notice the y-coordinates are the same here. Y equals constant, horizontal line, and horizontal lines have 0 slope. Alright, so no defined slope means vertical line. 0 slope means horizontal line. And horizontal lines and vertical lines are by definition perpendicular, so your answer to this example should be the lines are perpendicular. Okay? Alright, we're reaching the 28-minute point. We'll call it a day. This concludes section 2.3, slope of a line.